The Ohio Supercomputer Center is made available for the entire university system in Ohio, as well as Ohio industry. In the commercial space, we're really looking at modeling and simulation to improve product design, make things better, cheaper, faster. On the academic side, we support all aspects of science and engineering, everything from nuclear engineering, aerospace engineering, to biology and medicine. They're customers who need high-performance computing services. Our new Dell EMC Intel cluster, Owens, provides a robust increase in the overall capacity for the center.
For the architecture of the Owens cluster, we've built the systems based on the Dell EMC PowerEdge 6320 servers. These include the Intel Xeon E5 2680V4 processors. So we picked that particular Intel processor because of the superior memory bandwidth and the superior floating point performance. It also has a broad set of HPC applications that are already well supported on the platform. The Intel processors support the AVX2 instruction set. And this will be a good first step for our users towards the Intel Xeon Phi processors, which introduce an even wider vector instruction set. The total number of cores in the system is a little over 23,000. The peak performance of the Owens cluster is 750 teraflops, 4 times the peak performance when we compare it to the existing systems. With the Dell EMC and Intel system, researchers will be able to run larger problems, and it'll have significant benefits for their research.
We do mostly molecular dynamics simulations on polymer materials. So polymers are these long chain molecules composed of the same chemical unit repeated many times. And one of our main projects is to create easier, cheaper, safer battery materials. We often have the problem that we have to wait long simulation times before things happen. So we're often hitting the wall time of 4 days. And so now moving to Owens, we can literally run the same simulation twice as fast. It really lets us focus all of our energy on the scientific questions we want to address that could impact people's lives.
We're very excited to deliver this capacity to our customers. We have clients like Ray Lito at TotalSim, where OSC provides a competitive advantage for Ray is in an ability for him to run larger simulations for computational fluid dynamics.
TotalSim is mostly an aerodynamic consulting company, but we do most of our aerodynamics in computational fluid dynamics, or CFD. CFD is highly dependent on high-performance computing systems to get this work done in a timely fashion. One of the great things about the new cluster here at OSC Owens is just the sheer core count and memory is going to allow us to, in the same time period we could on the old clusters, run a higher fidelity model, larger models, more models, and get more work done in the same time period. It allows us to think bigger, think in more detail, and think about doing these things that we had previously dismissed because they were just too time consuming.
The new Owens cluster is a much more efficient system from the perspective of how much power it takes for the amount of performance that we get out of the system. We installed the Owens cluster in the same footprint where an older system was previously installed, and they required a very similar amount of power, except the Owens cluster has about 25 times the peak performance of the old system. So that's a remarkable improvement in efficiency.
Having an integrated solution with Dell, EMC, and Intel allows us to provide higher reliability for our customers. We know we're getting best-of-breed solutions in the marketplace. We expect and we get higher reliability, higher levels of service, and an opportunity for us to not focus as much on the details of our hardware and to focus more on what our customers need.